All right, in this lesson, we're going to talk about the other three triangle congruence theorems, which are side, angle, and angle, side. So remember, whenever you're using, there are 5 in total, and whenever you're using these 5, you're using them to try to prove that two triangles are congruent, hence the name triangle congruence theorems. So prior knowledge to look for in diagrams, you guys want to make sure that you're always looking for your vertical angles and label them first. So these are freebies and we'll give you an extra piece of info to help you figure out what theorem that you can use. So now we have experience with all 5 angle theorems. So if you see triangles in an example that looks something like this, what you can see is, hey, I know already that these 2 angles are congruent because vertical angles are always congruent. Now you are one step closer to figuring out a theorem that you can use. You also want to look for if you have the triangles sharing a side, right? So let's say even, I'll draw a slightly different example. If we have triangles that look like this, we can go ahead and label that shared side with the X or with tick marks. So in a proof, we know we'll use reflexive property, but also, again, it's the idea of like getting a free piece of information to get closer to using one of these 5 theorems. Other things to look for, remember, if we have parallel lines, we should be looking for our angle pair. So if we know 2 lines are parallel, and in a diagram, maybe we'll have something like this, where we have 2 sides of a triangle are parallel. Again, we should be looking for our alternate interior angles, right, which is the Z. We can also look for corresponding angles, but to be honest, in triangle diagrams, you're mostly going to be using the alternate interior angles, but you might see other examples as well. Also, only use given information. You can never assume anything. For example, if you're not specifically told that an angle is 90 degrees, you can't just draw a box just because it looks like it. And again, make sure you're labeling your diagram after every statement and reason that you write. You want to make sure that the labels on your diagram match the labels or match the statements in your proof. All right, first theorem, and you guys want to make sure you're studying these theorems. If you don't know the theorems, it's going to be really hard to work through a proof. So first theorem is SAS, which stands for side, angle, side. It says if 2 sides and the included angle are equal to 2 sides and the included angle of another triangle, then we can say that the triangles are congruent. So you can use the letters to tell you exactly what you need, right? Side, angle, side. In this, my angle is in between my 2 S's. It's in between my 2 sides. So in an example, we can see here, we have our side, our angle, and then the other side, right? So our angle is directly in between the 2 congruent sides that we have. Same thing here. We have our side, our angle is right in the middle, it's like sandwiched in, and a side. Now, an example where you might need to use some vertical angles lies in this here, right? So right now we have labeled that AC is congruent to CE, and that CD is congruent to BC. Right? So if we're asked what theorem we can use here, right now we have nothing. But remember, when we have 2 lines intersecting, when we see that X shape, we can look for our vertical angles, right? So with my prior knowledge, I know that angle ACB is congruent to angle DCE because vertical angles are always congruent. Now, here we can see we can use side, angle, side, right? And it kind of goes like you can use the letters and start at a point. So if I start here, I know I should have a side, an angle right next to it, and a side. Right? And in this example, again, we have side, angle, side. Therefore, I'm able to use side, angle, side to say that, hey, triangle ACB is congruent to triangle DCE because of side, angle, side. All right, now, again, we have some examples. Now, I wanted to show you guys a non-example of this as well. So in this case here, in this non-example, in the first triangle, we have side, angle, side. So our conditions hold, right? We have 2 sides, and then there's an angle right in between those 2 sides. But in our other triangle, if you look, we do have the 2 congruent sides, but the angle that we have information on is not directly in between our sides, right? So that angle that we need information on would be this one, and we don't have that. So in this example, then, we're not able to use side, angle, side. Side, angle, side can't work because our angle isn't directly in between. So we also have angle, side, angle here. Now for angle, side, angle, again, it goes with the letters that we have. So in this case, we have 2 angles that are congruent, and then the side right in between them has to be congruent as well. So in this example, we have an angle, a side, and an angle. And again, in the other triangle, we have that congruent angle, a side, and an angle. So that would work. Now, some examples where you might need to use some other knowledge here. In this triangle here, in this example, I see a shared side. So we can go ahead and put a little X there. So in my red triangle, I have an angle, a side, and an angle. And then in my blue triangle, again, I have that angle, a side, and an angle. So I can use angle, side, angle to conclude that those two triangles are congruent. Next, I see my intersecting lines. So when we have that, again, we want to look for our vertical angles. I see my x, my congruent angles are here. And again, angle, side, angle, angle, side, angle. Now here's another example of a slightly more complex diagram, but again here you can see in the red triangle, and sometimes it helps to highlight in different colors. In the red triangle we have an angle, a side, and an angle, and in the blue triangle we also have angle, side, angle. Now angle, angle, side, again you can just follow the letters, right? We have two consecutive angles, but that side does not need to be directly in between our angles, right? So if I start here, I go angle, or I'm going to start at the B, I go angle, angle, side, right? Here I go angle, angle, side. Use the letters to help you. The side does not need to be directly in between your angles here. Now here's another example, and again you want to look for your triangles sharing a side. I can see my shared side right here, so I can put that X. And another piece of advice that I have, like if your triangles are drawn together, it might help to separate them and carry your labels over. Now what I mean by that is I'm going to relabel my congruent angles here and my congruent angles here, right? Now if I label that reflexive property in both of my diagrams, you can kind of see a little bit better here how it's angle, angle, side, and then angle, angle, side. Now, make sure you know the difference between angle, angle, side, and angle, side, angle. Now, it's the letters that tell you exactly your conditions, right? In angle, side, angle, my side needs to be directly in between my angles, right? In angle, angle, side, that is not the case. So here's some visual examples. And again, angle, side, angle, your side is directly between your two congruent angles. And then in angle, angle, side, your side is not in between the two angles. So in angle, angle, side, we have our side that lies outside. It doesn't have to be sandwiched in between. All right, awesome. So if you guys have, make sure you understand, like, refresh your definitions of these theorems, and then we're going to practice applying them a little bit as we work on some practice problems.